Hello students, welcome back to today's topic on coordinate geometry. Coordinate geometry is a very interesting topic as well as a very easy topic to understand. You have already learned in the previous classes about coordinate geometry. Further to that, more applications and more concepts that we are going to cover in these lectures, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is coordinate geometry all about? The first one we're going to discuss about coordinate plane. Right? You already discussed in the previous classes what is a plane, what is axis, what is x-axis, what is y-axis, and how to plot points. Once again, let's try to discuss all this, right? So we have two perpendicular lines, one horizontal line and one vertical line. The horizontal line is always called as x-axis and the vertical line is called y-axis. This xy plane means the surface which you are seeing, the screen which you are seeing is a plane. The paper on your writing, that is a plane, right? It's just a plane. Okay, so a coordinate plane means which has all the points with one reference point, that is exactly that is a point of intersection of x and y, which we denote with 0, 0. What is the meaning of 0, 0? On x-axis, from x-axis it is at a distance of 0 units, as well as from y-axis it is at the distance of 0 units. Simply, that is a basic reference point to plot all other points on this plane. That is a basic reference point. This point is called origin. This point is called origin. That is the starting of the plane. That is origin means that's the starting. Every other point, every other measurement that we're taking on the plane is with respect to the reference 0, 0. If you consider at 1 unit, when I say 1 unit, it may be 1 centimeter, it may be 1 kilometer, it may be 100 kilometers. It depends on the usage. It depends on the usage. Okay, so here it is 0, here it is 1. So this is the point 1. This distance is 1, and always the distance is calculated or denoted using the reference point 0, 0. Right? And again at some distance, the same distance again, we get here 2. The same distance we get here 3. So 1, 2, 3 on x-axis. And as we plot the numbers like this, with respect to 0, all the numbers to the left of 0 are negative numbers. All the numbers left of 0 are negative numbers, right? So this is 0 to 1, here we have 0 to -1, and again after that we have -2, and after that we have -3, and so on. As this is a reference system, that is all positive, the other side should be negative numbers. In the same way, on y-axis, the top numbers, the up numbers are considered as a positive. At the same distance, we have the number 1, and then we have number 2, right? In the same way, in the negative direction, the same distance, you have -1, you have -1, you have -2, -3, -4, -5, so on. So it is a never-ending plane, it continues forever. These are two lines, axes are lines, they are never-ending. Right? So this is how the numbers and the units are placed with respect to coordinate plane. Okay, which we have already discussed in the previous classes. Let's try to understand how to plot few points on x-axis as well as on y-axis. Okay, where do these following points lie? -4, 0, 6, 0, -8, 0 on the coordinate plane. And I told you -4, 0, which means that the first point is always with respect to x-axis, the second point is always with respect to y-axis. So on x-axis we need to move to -4. This is x-axis, 0, -1, -2, -3, and this point is -4. On x-axis, -4 is good. But on y-axis 0, that means that we should not move anywhere along y direction. We should not move anywhere along y direction. So whatever we have obtained in the x position, so this itself is the point -4, 0. This itself is the point -4, 0. And now about 6, 0. Okay, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So this point is 6 comma 0. This point is 6 comma 0, correct? And minus 8 comma 0, although my graph stopped here, we can still extend that to minus this minus 4. The same way, you'll have minus 5, you have minus 6, minus 7, and you have minus 8. So this is the point minus 8 comma 0. Okay, so all these points you can simply say that these are the points on x-axis. Wherever you find the number 0 in the second ordered pair, that means in the position of y, all these numbers are the numbers, all these points are the points on the line, on x-axis. All these points are the points on x-axis. Okay, so now let's try to find the distance between 2 points on x-axis. Let's try to find the distance between 2 points on x-axis. Points on x-axis will be always in the form of x comma 0. Just now I told you. 1 comma 0, 2 comma 0, 3 comma 0. All these points are the points on x-axis. Now, let me plot 2 points, 3 comma 0 and minus 5 comma 0. So 3 comma 0 is somewhere here and minus 5 comma 0 is somewhere here. The point now here is we need to find the distance between these 2 points. If you carefully observe, from origin, okay, the distance from origin, this is 3 units and this is 5 units. Don't say the distance as negative. Don't say this as a minus 5 units. Don't say this is minus 5 units. So this is 5 units. Distance can never be negative. Please try to mind that. Distance can never be negative. Although the point says that minus 5, it is just to say that it is in the negative x-axis direction. The distance is 5. So now the distance from this end to this end, or this end to the end, this end, 5 plus 3, 5 plus the total, we have 8. We have total 8 units. The distance between 3 to minus 5 is 8 units. And how do you get this 8 units? If you have x1, this one, if it is x2, x1 comma 0 and x2 comma 0, the thing is, this is the difference between these 2 numbers, correct? Difference from minus 5 to 3, whatever we're having, that is the distance between them, right? So x1 minus x2 will be the distance between these 2. But when you're trying to find x1 minus x2, sometimes x1 minus x2 can be negative, That's the reason we keep the distance as modulus. These 2 lines represent modulus. Okay, what do you mean by modulus? Modulus is nothing but if we get a negative answer, we should convert that to positive. Let's say you got minus 8, but the distance cannot be negative. You need to keep it as a positive, plus 8. The distance is minus 10. No, the distance is 10. You need to keep modulus. Modulus of minus 10, if you get, you should not consider negative value. You should directly consider the positive value. The positive value is 10. The positive value is 10. Right? So moving ahead, distance between 2 points on x-axis. The distance between 2 points on x-axis, again the same thing. Find the distance between 7 comma 0 and 5 comma 0. Okay, so 7 minus 5 is 2. It is a positive quantity. So the distance between these 2 points is 2 units. You can say the distance between these 2 as 2 units. Minus 2 comma 0 and 1 comma 0. Minus 2 comma 0 and 1 comma 0. So we can say that minus 2 and 1, the difference between these 2, minus 2 minus 1. x2 minus x1 or x1 minus x2, which will give you minus 3. But we should not say distance as a negative. So modulus of minus 3 will give you 3 units. Modulus of minus 3 will give you plus 3 units, whatever it is. Okay, it may be centimeters, it may be meters, depending on the questions. Okay, so let's move forward for the next one. Distance between 2 points and parallel to x-axis. Find the distance between points 7 comma 3 on a line, you can say on a line parallel to x-axis. Okay, 7 comma 3 and 15 comma 3. Let me plot these 2 points on x-axis. 7 On x-axis 7 and on y-axis 3 units. So on y-axis 3 units, so 7 comma 3 will be a point here. 7 comma 3, and we should also write 15 comma 3. Let us erase that. Let's try to write it more near. Okay, so 7 comma 3. 7 comma 3 will be here, 7 comma 3. In the same 15 will be here. So 15 comma 3. Right now. So these 2 points are points on the line which is parallel to x-axis. Same parallel to x-axis, correct? So the distance between these 2 points or the distance between these 2 points is same. The distance between these 2 points and the distance between these 2 points is same. So simply ignore 3 and 3. Just try to find the difference between these two. 7 minus 15 or 15 minus 7. 15 minus 7 will give you 8 units. The distance between these 2 points is 8 units. The distance between these 2 points is 8 units. Okay. Now again, 5 and 5 both are same. So just ignore that. 9 minus of minus 2 will give you 11 units. That is the distance between these 2 points. If you want, you can take a graph paper. You can plot these points exactly, and you can take the scale to measure the distance between these two. That becomes 11 units. That will give you 11 units. Okay, so moving ahead. So now distance between 2 points on y-axis, it is again the same thing as x-axis, but just the point notation is different, where the points will be of the form 0 comma y. 0 comma y, x comma y, x becomes 0. That means we should not move in x direction. We should not move in the x direction. We should only move towards the y direction, vertical direction. Okay. So 0 comma 6, where is this point? In x-axis 0, so we should not move anywhere towards the x-axis. No horizontal movement, but only vertical movement for 6 units. So that will give you 6. So this point is 0 comma 6. Only on x-axis. The point is only on the x-axis. Okay. 0 comma minus 3, which states that it is a negative region. So 0 comma minus 3 is the point here, right? So now how to find the distance between these two? This is 6 units and this is again 3 units. So 6 plus 3 is 9 units. Simply the difference between 6 and minus 3. Simply the difference between 6 and minus 3. Okay, so the distance between A and B, 0 comma y1 and 0 comma y2 is difference of y1 and y2 with 2 lines which says it is modulus meaning that it should be considered only as a positive value. Modulus states that it should only be a positive quantity. Okay, so moving ahead, we can say that distance between 2 points on y-axis. Once again, let's try to take some examples. As these two are zeros, so simply ignore that directly. 1 and minus 5, the difference between 1 and minus 5, so 1 plus 5 will give you 6. So the distance between these 2 units is 6 units. 0 comma 3 and 0 comma 7, 0 and 0, just ignore that, and 3 and 7, the distance is 7 minus 3, 4, which is a positive quantity. It is enough to say that the distance between these 2 points is 4 units. Right, so let's move ahead to see the next one. Distance between 2 points on a line parallel to y-axis, okay. 7 comma 3 and 7 comma 13, if you carefully observe, x values both are same. 7 comma 3, this is 7 and this is 3. 7 comma 3 and 7 comma 13. So we need to find the distance between these 2 points. So what is the distance between these 2 points? 13 minus 3, which is 10 units. 13 minus 3, which is 10 units, correct? Okay, so simply the same 7 and 7 can be cancelled directly. So 13 minus 3 will give you 10 units. This is a positive. It is enough to write it as 10. Minus 2 and minus 2 gets cancelled. 9 minus 5. 9 minus 5 will give you 4 units. 9 minus 5 will give you 4 units. That is the distance between these 2 points. Right? So moving ahead, let's try to understand the distance between 2 points on x comma y plane, which is a very, very important. Till now, we discussed the distance between 2 points on x-axis or 2 points on y-axis. But now, let's try to understand what is the difference between 2 points on xy plane. On xy plane, that means the points are in the form of x1, y1 and x2, y2. So the formula to find the distance between these 2 points is root over x2 minus x1 whole square plus y2 minus y1 whole square. How we get this, what is the proof or the derivation, that we're going to cover in the coming lectures. But now you need to understand the formula is root over x2 minus x1 whole square and y2 minus y1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square. Let's try to take one small example and let's try to relate with this formula. Okay, so find the distance between the points of 4, 3 and 8, 6. So this is x1, this y1, x2, y2. The distance between these two will be root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square. So x2 minus x1, 8 minus 4, 8 minus 4 whole square, 8 minus 4 whole square plus y2 minus y1, 6 minus 3 whole square. So what is 8 minus 4? 4. 8 minus 4 is 4, so 4 square plus 6 minus 3 is 3, so that is 3 square. 4 square is 16 plus 3 square is 9, so 16 plus 9 is root 25. 16 plus 9 is root 25 and root 25 is equal to 5 units. Root 25 is equal to 5 units. So the distance between these 2 points 4, 3 and 8, 6 is 5 units. Right. So moving ahead. Find the distance between the points a, b and minus a, minus b. Should be very careful here. x1, y1, x2, y2, and you know the formula for the distance between these 2 points. D is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square. So that is equal to root over x2 minus x1 minus a whole square plus y2 minus y1 whole square minus b whole square. y2 minus y1 whole square minus b whole square. Minus a becomes minus 2a whole square and minus b becomes minus 2b whole square. So that will give you minus 2a whole square. Negative into negative will give you positive, right? So 2 square is 4, a square is a square plus 4b square. So if you take 4 common, you will get a root 4 into root over a square plus b square, and that root 4 you know which is equal to 2 units. Root 4 is equal to 2 units, so that will equal to root 2 root a square plus b square. That will be equal to 2 root a square plus b square. Right? So let's move forward for one more application based on all this. Find the distance between 1, minus 3 and minus 4, 4 and round it to 2 decimals. That means we will be getting some root over some number. We need to find the exact round it to 2 decimals. Okay, so let's try to find x1, y1, x2, y2. So root over x2 minus x1 whole square minus 4 minus 1 whole square plus y2 minus y1 whole square 4 minus of minus 3 whole square. So minus 4 minus 1 whole square is minus 5 square. Minus 5 square plus 4 minus of minus 3 is 7 square. So minus 5 whole square is 25 plus 7 square is 49. So 49 plus 25, how much is that? 49 plus 25, 9 plus 5 is 14 and 14. 4, 5, 6, 7. So that will give you root 74. So how to find root 74, that we have discussed already in the lower classes, how to find the square root. But still, if you have any doubt in trying to find what is a root 74, so that we are going to cover in the next coming lecture. And this 74, we will be writing it as 74.000000, right? And from there, we're going to try to find square root, which we have already discussed in the previous classes. Right, so that we are going to discuss in the coming class, and we have a couple of more applications. Find the values of y for which the distance between these 2 points is at 10 units. So x1, y1, x2, y2, the distance between these 2 points x2 minus x1 whole square, 10 minus 2 whole square plus y2 minus y1 whole square, y minus of minus 3 whole square is equal to 10. Right, so root over 10 minus 2 is 8 square plus y minus of minus 3 is y plus 3 whole square is equal to 10. So from this point, I'm leaving this question for you. So please try to solve that to get the value of y, and then you can understand the next coming things. Okay. So what else we're having next? The thing is, in the previous question, you need to do squaring on both sides. You need to do squaring on both sides. So 8 square is 64 plus y plus 3 whole square is equal to 10 square is 100. What we're doing? We're doing squaring on both sides. We're doing squaring on both sides. Okay. So y plus 3 whole square is equal to 100 minus 64, which will give you 36. So from there you can try to find the value of y. One important thing, when you try to remove square, you need to keep plus or minus. When you remove square, you need to keep a plus or minus. So y plus 3 whole square. Okay, just a minute. Let me write that once again. Yeah. So y plus 3 whole square is equal to root 36 plus or minus root 36. Okay, square will not be there. Root plus or minus root 36, which is equal to 6. Y plus 3 is equal to plus or minus 6. So y equal to plus or minus 6 plus 3. So y equal to 6 plus 3 as well as minus 6 plus 3. So y will get as 9 as well as minus 3. So 9 comma minus 3 are two values which satisfies this condition that the distance is 10 units. But once again, I am leaving this question for you to please try to solve it once again with every step clearly so that you can understand more better about the application, right? So we have many applications based on all this, so that we are going to discuss in the coming lecture. I hope you understood and you enjoyed this lecture. Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we'll be discussing about the lens formula. What does the lens formula do? It gives us a formula or a relation between object distance, the focal length of the lens and the image distance. Okay, we'll go into the formula and all in today's class. So my name is Shashan Reddy. I'm a graduate from IIT NEETFoundation. Let's go into the class. So first of all, before going into the formula, we have to go into something called as sign convention. Right, because object distance, image distance and focal length, and our formula can be both positive and negative. So how do we decide which is positive? How do we decide which is negative? Positive and negative are sign, right? So there are a few rules for that, and those rules we have to learn first. Sign convention deals with those rules. Okay, and when it comes to a lens, we know that optical center, which is exactly the geometrical center of the lens. That optical center, you can imagine it as what? You can imagine it as origin. And then you can take two axes, two perpendicular axes, x-axis and y-axis. Simple. Here the question is, which direction will be positive? Normally, if I take coordinate geometry, coordinate axis, towards right is positive, towards left is negative. Negative x-axis and positive x-axis. Good. That is a normal coordinate axis or coordinate geometry. But when it comes to lens, there's a different rule for choosing the direction of positive axis. What is that? Right? That depends on what? That depends on the direction of incident ray. The positive direction will depend on direction of incident ray. Okay, I'll go into all of them. Don't worry. So here, I'll just take a simple lens. If this is convex lens, there will be a principal axis which passes through optical center. So that principal axis, this principal axis, we take it as x-axis. So principal axis is also nothing but x-axis. You can also say the same for a concave lens also. It is fine. For a concave lens also you can say the same. If this is principal axis, we consider principal axis as x-axis. Simple, straightforward. But here what more important is the direction of the positive x-axis. How is it going to be? We'll understand that from here. Okay, so here, just a minute everyone. Yeah. Here you can see a convex lens. We have two f1, we have f1 O optical center, f2 second principal focus, and 2f2. We are not concerned with the center of curvature, no. These are the points we generally consider. Okay, so here what's happening is, the incident ray is coming in this direction. So if you can look at the incident rays that I am drawing here, look at them. They are generally in which direction? Along the principal axis, they are towards right. That means towards right will be positive, or you can say towards right is the positive x-axis. Now then comes the question, sir, what if the rays are coming from the other direction? That is, they are coming from right. Here they are coming from left, let's say they are coming from right. That means if I take a convex lens, if this is the principal axis, and if there is an incident ray in this direction, then what will we do? Again, it's very simple. Look at the direction of incident ray. It is towards left. And so, in this case, left will be positive. Okay, and mostly you will not get this case. Mostly you will not be getting this case. Mostly we will be dealing only with this case. But to be sure, let me explain. So if the incident ray is coming from right, that is, it is going towards left, then the left direction will be positive and the right direction will be negative. Now here something interesting happens. For a convex lens, you have to always think in terms of the direction of incident ray. So the incident ray is coming like this. So it will come across a focus. Obviously it will come across a focus here. Now that focus, is it the first principal focus or the second principal focus, everyone? Is it F1 or is it F2? That is the question. Yeah? Can you please answer that? Is it F1 or is it F2? Yeah? See, for a convex lens, in the direction of incident ray, the first focus will be the first principal focus. So here even the focus, whether it is the first principal focus or the second principal focus, will depend on what? Will depend on the direction of incident ray. They could be like this also. Mostly they should be going towards left. See, they are going towards left. So the first focus that they will come across is F1 and then they will come across F2 in the case of a convex lens. I think we discussed about that. Right, again coming back to the sign convention. Which direction is positive? That is the most important statement. Which direction is positive? Yeah, everyone? The direction along the principal axis in the direction of incident ray. Direction of incident ray is taken to be positive. Simple. Okay. And again, when it comes to height, upward heights are positive and downward heights are negative. You can just say upward height is positive and downward height is negative. Simple. No confusion there. That's it. Okay. So that was for a convex lens. Now we'll also have a concave lens. Now for a concave lens, what happens is, look at this, this is the direction of incident ray. Along the incident ray, the first focus that we are coming across is not F1 but F2. See, along the incident ray, the first focus I am coming across is F2. So concave and convex are slightly different. We come across F2 first. But the rule again remains the same. Here the ray is going towards right. So towards right is positive and towards left is negative. Obviously we have the other case also. Let's say this is the concave lens. This is the principal axis, and if I take the incident ray in this way, and if there is a focus here, is that F1 or is that F2? Can you tell? Is that F1 or is that F2? Everyone, think about it. For a concave lens in the direction of incident ray, the first focus that we come across is F2, not F1. That will be what? That will be F2 in this case. And obviously the other one would be F1. In between you have the optical center. Then, now again here, which direction is positive? Which direction is positive? Can you answer? Left or right? In the direction of incident ray, the direction of incident ray is generally, or along the principal axis, it is towards left. Towards left. So that means left will be positive and right will be negative. And as usual, you will not get this case mostly. Mostly we will be dealing with this case. But it's better to know things properly. Okay? Understood? Even here, upward heights are positive, downward heights are negative. As simple as that. Okay? Good. Now let's continue. Let's summarize all the points. Read the points carefully here, everyone. The direction of the incident rays along the principal axis is considered positive x-axis or positive. And the opposite direction is negative or negative x-axis. That is along the x-axis. And one more important point is the distances are measured from which point? They are measured from origin. But what is origin here? The optical center of the lens. Optical center of the lens is the origin. So the distances, it could be of object, of image or of focus. Focal length itself, they are measured from the optical center, which will act as the origin. Okay? Good. Wonderful. Let's continue. And again you can clearly see height is measured perpendicular to principal axis. Upward height is considered positive and downward height is considered negative. A very simple statement. Good? Okay. So as until now all the points are similar to what? Similar to mirrors, the spherical mirrors, so you can compare with them. Good? Okay. Let's continue. Now there is one interesting thing. As we discussed, the object is generally considered to be placed to the left of the lens, always. I mean, for our case, at least for class 10th, we take it to be towards left of the lens, generally. This implies that, look at the direction, if this is the object, the rays come from the object, that means look at the direction of rays, the light direction is what? Generally towards right. So generally we take towards right as positive and towards left as negative, mostly. Okay. And here there is one important point. Object distance is always negative. Object distance is always negative because you can clearly see that here. If this is the optical center, I told you, you have to measure distances from where? From the optical center. So from the optical center to the object, in which direction are we going? We are going towards left. So object distance is what? Is negative. Why? Because here towards right is positive and towards left is negative. That is the reason why from optical center towards the object I am going towards left, and left will be negative. And remember this point blindly. Object distance is always negative. It could be for a spherical mirror, for a spherical lens, anywhere and everywhere. Okay, there is one condition, a real object. Good. Let's continue. Now there is one interesting question, as I told you. That is, if I take a convex lens, this is optical center. So let's say this is F1 and let's say this is F2. Now for focal length, which focus should I take? Because ultimately it will have only one sign. So if I take it as, let's say here, F1, it is towards left, it will be negative. right? In this case, left will be negative. But if I take it towards right, it will be positive. So which one do I take? Do I take F1 or do I take F2? That is one interesting question. For focal length, what do you take? And what do you take? You take the sign convention of what? You take the sign convention of F2. So for focal length, which focus do you consider? You consider the second principal focus. Not the first one, but the second principal focus. Understood? For focal length, consider the second principal focus always, whether it be a convex lens or a concave lens. So that means, what does that prove? What does that show us? What that shows us is, for a convex lens, focal length is positive. For a convex lens, focal length is positive. Towards right is positive. So from optical center, we are going towards right, positive. But if I take a concave lens, let's say the incident ray is something like this. So in the direction of incident ray, you first come across F2 for concave lens. Then optical center here and then F1 somewhere here. So here the incident ray is towards right, that means towards right is positive, towards left is negative. So for a concave lens, if you look at the focal length, which focus? F2. So from optical center towards F2, and in which direction am I going? From optical center to F2, we are going towards left, and left is negative. So here focal length will be negative. So that shows that for convex lens, focal length is positive. For concave lens, focal length is negative. Okay. So keeping all that in mind, we have got three different cases until now. Right, what are they? Look at this. The term convex lens, and sign is what? Positive. What we are talking about? The focal length. They'll say focal length of convex lens. Focal length of concave lens. What about concave? It is negative. And object distance, as usual, always negative. So please remember this so that you will not be confused and you can easily solve it at any point of time. Understood? Remember the table. All the information given on this table is very, very important. And obviously, if you read this point, the focal length is measured from the optical center to what? To the second principal focus. You have to only focus on second principal focus. Forget about the first one. Only focus on second principal focus. Got it? Good. Let's continue. So again, there are some terms. For object distance, we use U. Image distance, we use V. Focal length, we use F. Radius of curvature, we use R. And understand this, all these four, object distance, image distance, focal length and radius of curvature, will have their own sign. So to be careful about sign convention. Object distance, as we know, is always negative. So directly take U as negative. But for F, focal length and radius of curvature, you have to be careful. Okay. For a concave lens, focal length is what? Focal length is concave lens. Focal length is negative. Convex lens, focal length is positive. Okay. So we understood how to get the proper sign convention. We understood how to get the image distance or the object distance. You have to measure from the optical center. Right. Okay. Now we'll go into the formula part. So this here is the formula. 1 by V minus 1 by U is equal to 1 by F. Sir, what about derivation? We'll do that in a separate class, the next class, separately. But for now, we'll only understand this. We'll look at how to use this formula. Here, what is V? V is image distance. What is U? U is object distance. What is F? F is focal length. And here, when you use this formula, it is used for a lens. You can use it for any lens, for a convex lens, for a plano-convex, concave, plano-concave, concavo-convex, convexo-concave. doesn't matter. You can use this formula for each and every lens. Okay, but you have to be careful. That is, you have to substitute with proper sign convention. If V is negative, you have to take it as negative. If V is positive, you have to take it as positive. Should be substituted with proper sign. Let me write it down. Should be substituted with proper sign. Okay, so let me show you something here. When it comes to a spherical mirror, that should be substituted with proper sign. When it comes to a spherical mirror, it could be a concave mirror or a convex mirror. What was the formula? 1 by V plus 1 by U is equal to 1 by F. But when we talk about a lens, obviously a spherical lens, we take the formula as 1 by V minus 1 by U is equal to 1 by F. So the formulae are almost similar except for the sign. In the spherical mirror it is positive, but in the case of a lens it is negative. You have to take addition and subtraction. Right, that is the difference. Good? Okay. So let's go into one simple question to try solving it. Okay. So let's go into this question here. What is this question here? Look at this. An object is placed 50 centimeter away from a convex lens of focal length 20 centimeter. Where is the image formed? An object is placed 50 centimeter away from which lens? Convex lens. At what distance or of what focal length? 20 centimeter. So the first thing will be to draw the given information, write down the given information. You can draw a rough diagram to get an idea. Let's say this is the convex lens, focal length is 20 centimeter. For convex lens, focal length is positive. You can directly take it as positive. So here this point, let's say it is F1. This point will be 2F1. The focal length is 20 centimeter. 2F1 will be at twice the distance. 2 into 20 is 40. But the object position, just a minute. I think remote is not working. Let me continue with this. So the object position, the object length is how much? 50 centimeter. So the object is 50 centimeter away from a convex lens. So the object should be here somewhere. So that the distance from the lens will be 50 centimeter. So where is the object? The object is placed beyond 2F1. The object location is important. It's placed beyond 2F1. Right? And so from the table, from the ray diagram for a convex lens, if the object is placed beyond 2F, you will get the image between F and 2F. Okay, so let's try verifying it, but now let's go into the information. Given information, you can clearly see object distance always negative, so minus 50 centimeter. And then if I go into the focal length, for a convex lens, focal length is, we have to talk about F2 here. F2 is somewhere here. So yeah, F2, not F1. You have to take care of F2. So here the focal length for a convex lens is positive, that is going to be 20 centimeter. So you have object distance, and you have focal length. Now we can get the formula. Which formula do we use? We can use 1 by V minus 1 by U is equal to 1 by F. This is the formula of what? Of a lens. So everyone please substitute and solve it and let me know the answer. Please solve it. You have the given information. All that you have to do is substitute and solve. Substitute carefully with proper sign and then solve. So let me solve it for you. Let me solve it then. 1 by V, we don't know V, we'll try to find out V, that's fine. Just a minute. Yeah. 1 by V, we'll find it minus. You have to be careful about the minus signs. minus 1 by u. What is u? U is minus 50, and which unit? Centimeters. Is equal to 1 by f. What is f? F is 20. That's it, see. Now if I just substitute and solve it, I will get the answer, right? So here you can clearly see minus minus cancel, minus divided by minus plus. It will become 1 by v plus 1 by 50 is equal to 1 by 20. I'll use this from here, I'll solve it. 1 by v plus 1 by 50 is equal to 1 by 20. So if I take 1 by 50 to that side, it becomes 1 by v is equal to 1 by 20 minus 1 by 50. Now I have to take the LCM of 20 and 50. What will that be? 100? Yes, so 20 into 5 is 100, minus 50 into 2 is 100. So 5 minus 2 by 100, which will be how much? 3 by 100. Is this the answer? No, because on the LHS we have 1 by v. We don't need 1 by v, we need v. That means you do the reciprocal. So v is equal to 100 by 3, which is how much? 33.33 centimeter. 33.33 centimeter, and you're getting it as positive. So what does positive and negative mean? See here, clearly see that here. Here if I look at the rays, okay, I'll only look at the rays. From the object, the rays we are going towards what? From the object, the rays here generally go towards right. And if they go towards right, then they fall on the lens. That means here the direction towards right is positive. And towards left is negative. And we got the image distance to be how much? We got the image distance to be positive 33.33 centimeter. Positive 33.33 centimeter. So the image will be somewhere here. Such that it is towards right, positive towards right, and the value is 33.33 centimeter. Is that clear? Understood? So once you get the object distance, the focal length, substitute in the formula, solve it, you will get the answer. Simple. Okay. So here, if I look at the image now, is the image on the same side of the object or on the other side? If the image was on the left side, we can say same side of the lens. But object is on the left side, image is on the right side, they are on opposite sides of the lens, or image is on the other side of the lens. That means if I look at this, it should be something between A and B, 33.33 centimeter. From the lens and on the other side of the lens, that means option B is the correct answer. Option B is the correct answer. Understood? Okay. Next. Sorry. An object is placed 50 centimeter away from a concave lens of focal length 20 centimeter. Same question. The only difference is we are making use of a concave lens. Where is the image formed? Now again let me solve it here. As usual, you have to take what? You have to first draw it, a rough diagram, so that you will get an idea of what you are doing. Right? The focal length is 20 centimeter. The object is placed 50 centimeter away. The object is placed 50 centimeter away. Right, so if this is the object, the incident rays will be something like this. So towards the right is positive, towards left is negative. In the direction of incident ray, we first come across F2 and then F1. Right, F2 is here and F1 will be somewhere here. Right, got it? Now, we have to find the image formed. So if you look at the object distance here, object distance. Now where is the object? On the left side. And how will you go? You will start from the optical center and go towards the object. From the optical center you go towards the object, that means towards left. And towards left is negative. Towards left is what? Negative. So object distance is equal to, or U is equal to What is given? 50 minus 50 centimeter. Or else you can always say that object distance is always negative. So you can take object distance negative. You need not focus on things. But here if I look at focal length, for a concave lens focal length is negative, so it should be minus 20 centimeter. In fact, even if you look at the diagram from optical center to f2, that is focal length, it is towards left and left is negative. Simple. Right, so you have object distance, you have focal length, both of them. We have to find out the image distance. Which formula for a lens? 1 by v minus 1 by u is equal to 1 by f. 1 by v minus u is minus 50 in brackets is equal to 1 by f. F is minus 20 in brackets. Then you can see minus minus cancel. So 1 by v plus 1 by 50 is equal to minus 1 by 20. There is a minus sign here. 1 by 50 will go to that side. 1 by 50 is equal to minus 1 by 20 minus 1 by 50.